Good evening, students. Today we are going to see about requirement in engineering. My dear students, uh, in last class we saw about what is software engineering, what is a software, why we need software, what are different kinds of software, and at one goals and objectives of software, attributes of software, and maintainability of software. We saw in first unit. In second unit, we saw what is the FDLC, why we know about FDLC, and we saw a diagram. We saw other models in FDLC, what is for incremental agile prototyping, rapid rate model, and we saw what is a cohesion and what is a coupling and what is abstraction. We saw 1 2 unit. Yesterday we were completed 2 units. In Okay, in this class today we are going to see chapter 3, requirement engineering. First, you tell me what is requirement engineering. Process to gather, to analyze and design is called requirement engineering. Okay, 1 minute. Yes, process to gather false requirements to client, analyze and document, then it is known as requirement engineering. So I write the definition. Understand the process to gather the software requirements from the client. Requirements from the client. Analyze and document. Analyze and document. Analyze and document. Then it is known as requirement engineering. Then it is known as requirement engineering. Okay. So, dear students, 1 minute. I will short it. The process to gather the software requirements from client, analyze and document. Then it is known as requirement engineering. Uh, listen, we are in requirement engineering. Requirement engineering means to from the client we are getting from analysis and we are getting. So what is client analysis? From the client we are getting, from analysis we are getting from the document, and it is an own requirement engineering. Next one, goal of requirement engineering is to develop and maintain sophisticated. The goal of requirement in engineering is to develop. Okay, you write this point. Develop and maintain sophisticated. Do SRS document. What is SRS document? What I told you? In SRS document, system requirement specification document. System requirement specification document. So I will explain. The goal of requirement engineering is to develop and maintain sophisticated and descriptive system requirements specification documents. So SRS, two SRS we are getting it. You write a short form. So develop and maintain sophisticated system maintenance system requirements specification document. So we are getting from specification document, right? Please make a note. Let's see one more topic. Okay, in this last topic only, I will finish top. Not enough. Now we'll see one more topic. Why we need so requirement engineering is for today. So why we need other things now? Requirement engineering provides a problem mechanism too. Requirement engineering provides a problem mechanism to understand what the customer desires. Understand what the customer desires. Next one, analyzing the need, assessing feasibility. Assessing, assessing feasibility. Assessing feasibility. Now, for fourth point, negotiating a reasonable solution. Negotiating a reasonable solution. Negotiating a reasonable solution. Specifying the solution clearly. Validating the specifications. Last one is managing the requirements as they transform. Transform into a working system. Okay, so requirement engineering objectives. Okay, please understand what the customer desires. Listen, understand what the customer desires. I will explain. Understand what the customer desires. So customer wants to decide a customer. Analyzing the need. Analyzing the need means that analyzing what we are doing. Assessing flexibility. Flexibility we can do it. Negotiating a reasonable solution that is reasonable we can do. Specifying the solution clearly. We can clearly do the solution. Validating the specification, we can do the specification. Managing the requirement, we can manage the requirements according to together. They transform into a working system as per requirements. Other they transform into the requirement into a working system. Requirement as the transform into the working system, we can do in the working according to that. Okay. Please note the requirement engineering definition, meaning, and what are the objectives of requirement engineering. Please note. We'll talk about that one. Okay, completed. Economy engineering chapter over. We'll discuss what is system modeling today. What is system modeling in third chapter also. It's very important. This is the last topic in economy engineering. So yeah, this is the last topic. That's fine. I'm going very quickly. I can. And I will finish portions as I can. Portions முடிச்சிருவேன். முடிச்சு எனக்கு கொஞ்சம் ஒர்க்லாம் இருக்கு. கொஞ்சம் ஃபாஸ்ட்டாக போயிடலாம். ஓகே. 7 தானே. ஸோ சாப்டர் 3 இப்போ பார்க்க போகிற டாபிக் பார்ப்போம். சிஸ்டம் மாடலிங். What is system modeling? Tell me. Just we can understand what is system modeling. Wait. அதே மாடல் எல்லாமே முடிச்சிட்டோம். ஜஸ்ட் கம்ப்யூட்டர் பேஸ் சிஸ்டம் நீங்க பார்க்கலாம். Software, hardware, people, program, database, documents, procedures. Software என்ன? Software வந்து நம்ம கொடுக்கிறது. Hardware, software we are giving hardware means that hardware we should give. Program na programs we can give. Documents we can give. Database we can give. Documentation we can provide. Provide procedures we can finish. Okay. Computer based system. Please make a note. Done. Good. Now we'll see what is system modeling. System engineering, I told you, system engineering is understanding of context. System engineering means system engineering is understanding the context. Understanding the key of context. I have to finish this. Next one can be a product or service or technology. System business engineering when used for business enterprise. Business engineering will use for business enterprise. Next one, product engineering when the product is to be fault. Product engineering when the product is fault. Product is to be fault. So the software engineering hierarchy, understanding the key of context. The context we can provide. Next one can be a product, service, or technology. Can be a product, service, or technology. Listen, we can provide understanding the key of context. We can understand. Can be a product, service, or technology. We can provide. Business enterprise, business engineering. To use for business enterprise, we can do product engineering, and the product is to be fault. So this one product engineering we can provide when the product is for business engineering we can use for business enterprise. Please take a note. System engineering chapter over. Please take a note. Noted. Your software engineering chapter, system engineering is over. Now we'll see a last topic. System modeling. What is system modeling? Just tell me. What is system modeling? I'm going to take class now. It's an important element. System modeling is a important element. Okay. Please make a note. I will finish the ways to discover and all. Please functional requirements. Functional requirements are not required. In non-functional, requirements are needed. So data flow model is a diametric representation of between a user and exchange within the system. These data flow diagram can be called as DFD. A neat and clear DFD can detect the system easily. Okay, so DFD is over. Now what is system model is an important element. It is important, very important. Interviews we can attend interview, survey we can do survey, questionnaire we can do. Okay, so your third chapter almost done. Okay. So what is a software design? Software design, listen, uh, it helps the programmer. Okay, it helps the programmer among implementation, coding and implementation. Easily implement using programming. So programming language we can do. Next one, correctness, completeness, efficiency, flexibility, consistency, maintainability. So what are the objectives? What is correctness? Software design should be correct as per requirement. Design should have a completeness like data structure, small and external interfaces. We can do all these things. This one should be spent efficiently by the program. By the program, we can do able to monitor and then we can do the changing it. There should not be inconsistency in the drugs. In the design, we cannot do. Design should be simple so that it can be easy handled by the other design. So we can do. Artificial design, abstraction, interface component, data structure, algorithm. So what if the article is defined? Identify the system we can identify, describe the system we can specify, describe the system interface we can do, discover the system interface in the components we can do, define data structure the whole problem that we can do, define algorithm for problem business, model function we can do. Okay. What if of the defined principle are concerned with the providing with the handle. So we can handle by coding and implementation. Abstraction of the I explained it. If a tool that enables the design to consider a component, we can consider a component, functional and data. More the way method is performed, the data are not difficult in the use of data. Morality, the one program that allows individual money to is very well defined, it has a single specific objective, it has a big compiler, it has leaves simple inside. A larger program, simpler overall procedure, more checkpoints, well defined, more viewable, high cohesion, and reviews again. Okay, long completion, long time. Perfect. Or is it the fourth liquid? Coding and loading time. In the more communication, more is required. Coupling and cohesion yesterday I completed. Different defined from the function viewpoint. Different definition. UI, you read what is SCM, identify, identification, basic, aggregate, version change, access interpretation control. Okay. Thank you, students. I will leave the class. Thank you. We'll meet in the chapter 4 testing. In next class, we'll see chapter 4. Thank you. Chapter 3 over. Thank you, students. Bye bye.